Hello and welcome to NHP's webinar on Integrated Energy Management. My name is George Janiszewski, Application Engineer for NHP Electrical Engineering. This is just one in a series of webinars created to showcase NHP's smart devices powered by smart distribution and embedding smart energy management into operational processes, providing our customers with better visibility into processes, data and analytics. The goal for today's webinar is to cover the following key points. We'll define what an Integrated Energy Management System, or IEMS, actually is, and we'll identify the objectives and benefits of having such a system. We'll look at the steps needed to develop an IEMS and take a look at the main physical components that would make up a typical system. And this will equip you with the necessary information to begin developing an effective IEMS solution for your organization. So let's start out by defining what we mean by an integrated energy management system. A good place to start is the ISO 50001 International Standard for Energy Management Systems, which defines it as a set of interrelated or interacting elements to establish an energy policy and energy objectives, together with processes and procedures to achieve those objectives. An IEMS is a plan that should be an integral part of any business strategy. It'll give you a clear business-wide strategic plan whose purpose is to enable you to follow a systematic approach in achieving continual improvement of energy performance, including energy efficiency, energy security, energy usage, and consumption. The integrated energy management system is far more than just a collection of energy meters installed at a site, as is so often thought, but rather it takes a holistic approach, bringing together all the aspects of energy, including water, air, gas, electricity, and steam. The WAGES, or WAGES acronym, and managing all of those in the context of a continuous business-wide management improvement process. The primary objectives of energy management are cost savings, resource conservation, and environmental protection. Expanding a little on these, the IEMS allows for optimal energy utilization throughout an organization. This is achieved by continually seeking to improve or optimize all the variables that you can control that affect energy performance in order to minimize energy costs and wastage, but without affecting production and the quality of your product. And this means we can all reduce our dependency on imports and enhance our energy security, our economic competitiveness, and our environmental quality. The primary benefit of an IEMS is cost savings across the organization through energy efficiency. Substantial savings of both energy and money can be achieved. Businesses can see typically 20 to 40% reduction in their energy use over time. Apart from the savings realized going to your bottom line, the benefits extend way beyond efficiency alone. An IEMS is based on a strategic plan that embeds energy management at every level of your business and facilitates best practices. It sets up policies, people, and continuous improvement processes to create and sustain long-term change. The energy management plan covers both high-level aspirations and concrete targets and assigns ownership of tasks and goals to specific staff. Processes become more efficient. Well-managed, maintained, and optimized energy-consuming assets and operating systems last longer and work better. You develop a reputation for energy efficiency, sustainability, and better use of resources that can strengthen your brand. Energy-efficient workplaces can be safer and more pleasant for your employees, contributing to better health and safety and increased job satisfaction. The IEMS provides a continuous platform for creating and implementing action plans, evaluating their progress, and measuring the improvements made. The environmental benefits of having an IEMS include things like reducing greenhouse gas emissions and the future environmental impacts of climate change. Greenhouse gases are those that contribute to climate change, with carbon dioxide being the most prevalent of these. The carbon footprint of your business is the amount of carbon dioxide and other greenhouse gases that your business produces. Some businesses have larger carbon footprints than others because of the amount of energy they use, the way that they deal with waste, and the scale of their operations. Emission reduction, particularly sulfur dioxide and nitrous oxide, leads to mitigation of harmful effects of acid rain. Reduced particulate emissions leads to improved air quality, and reduced oil exploration and transportation results in improved water quality. By certifying to a standard like ISO 50001 and having compliance with Green Star and Neighbours, etc., companies and organisations can demonstrate their commitment to sustainability to their customers, employees, investors and regulators. In so doing, companies and organisations can gain a competitive advantage in the marketplace by proving themselves as good corporate citizens. This can help enhance their brand and directly supports their marketing strategy. So, how to develop an IEMS? The real gains in energy efficiency are made when businesses take control of their energy consumption. Senior management must be clear about the organisation's commitment to energy management and ongoing energy performance improvement. This should include the formation of an energy management committee and a clear energy management policy that explains the key reasons for the focus on energy management. Identify areas of significant energy use and conduct assessments of current energy consumption through energy audits or installation of energy metering. Set objectives and targets that describe the high-level goals for energy management and the resources that have been committed for reducing energy consumption that are specific, measurable, achievable, realistic, and timed. Successful implementation and operation of energy management practices must include staff awareness and competency training. And finally, the continuous improvement cycle only works when the necessary changes are actually implemented. So let's have a look at some of the physical components that are needed to make up an IEMS. The physical components of an energy management system start with devices that measure electrical energy, water, gas, etc. This data from all of the energy meters is collected by a data gateway or aggregator that performs analytics to transform the raw data into a form that management can use to make well-informed decisions about the effectiveness of energy reduction measures and initiatives. These analytics are made available either locally or on a local area network for a smaller installation, or via a dedicated server-based system or a cloud-based system that collates data from many aggregators distributed around the nation or around the world. So let's take a look at all of these elements in turn, starting with meters and CTs. The humble current transformer, or CT, is a very important primary device in energy management. It allows a potentially very large current to be transformed down to a small, easily measured current, usually 5 amps, for measuring devices such as energy meters. And we'll look at those next. The CT has an iron core with a hole through the center for the primary current carrying conductor. The primary current flow causes a magnetic flux around the conductor, which induces a flux in the CT core. This flux links with the secondary winding wrapped around the core as shown in the image. The CT is arranged so that the current that is induced and flows in the secondary circuit, shown as IS in the image, is a faithful representation of the primary current, but reduced in magnitude by a precise ratio. Most CTs have a solid core like the one shown, but CTs with split cores are also available. These make it easy to clip the CT over a cable or a bus bar without disturbing any of the mechanical connections. There are also electronic CTs, which are not current transformers in the true sense, but rather current transducers. These commonly generate a 333 millivolt signal at full primary current, but require a dedicated instrument to interpret their signal. The next device to consider is the energy meter itself. The energy meter takes in the current signals from the CTs and calculates and displays the actual primary current value. Some energy meters, usually those rated for smaller loads, have built-in CTs that allow a direct connection of the meter to the supply lines. Some energy meters take that 333 millivolt signal from a current transducer and can make for a very fast installation, as quick connect plugs are often used with these types of CT/meter combinations. The line voltages are also connected to and are measured and displayed by the energy meter. The meter measures the electrical displacement angle between the current and voltage waveforms and displays this as power factor, commonly referred to as cos phi, or the cosine of phi. And from this data, it continually calculates the instantaneous values of apparent power, reactive power, and most importantly, active power. Active power is usually expressed in kilowatts and is calculated as the square root of 3 multiplied by the line voltage, multiplied by the line current, multiplied by a cosine of phi. You can see it displayed individually for the 3 lines in the image. If then we take our active power and multiply it by the passage of time, we have active energy. This value is stored in the energy meter, continually increments as energy is consumed, and provides a permanent record of the total energy consumed by the load. And you can see this value displayed at the top of the meter image above. Most energy meters take a form similar to that shown in the image, but some power devices like air circuit breakers or ACBs, molded case circuit breakers MCCBs, and transfer switches include an energy meter built right into the product. This makes it very convenient to include all these devices into an energy management system. So the next step in our journey of assembling an IEMS is the energy gateway device. The energy gateway gathers the quantities of interest, such as volts, amps, power factor, active and reactive power, active and reactive energy, etc., from all of the energy meters and energy capable devices in the installation. The gateway features a data logger that enables the long-term storage of the data so that historical performance can be easily compared with current performance in order to evaluate energy improvement initiatives. The gateway performs analytics on the data and presents an array of appropriately formatted charts and visualizations to enable clear comparisons of day on day, week on week, month on month energy performance, which drives good energy management decision making. The embedded web server allows data analysis to be performed using any network connected browser. The gateway also produces daily, weekly, monthly reports delivered by email or FTP, enabling facilities managers to monitor consumption and apportion billing in multi-tenancy situations. The gateway can monitor loads and generate alarms delivered via email or SMS text if loadings exceed or fall below nominated thresholds. The gateway can also automatically transfer data to higher level systems such as server or cloud-based platforms or BMS systems via FTP, HTTP, or Modbus TCP. Well, so far we have defined what an IEMS is. We've defined its objectives and benefits. We've looked at how to develop one, and we've examined some of the main components of a typical system. So finally, let's take a look at a case study that exemplifies the principles of an effective IEMS that we have discussed in this webinar. PanPac Forest Products Limited, established in 1971 in New Zealand's Hawke's Bay, is a community-focused company employing 400 permanent staff and around 450 contractors in the tree harvesting, production, engineering, and transportation aspects of its core forest products of radiata logs, lumber, and pulp. PanPac is one of the largest sawmills in New Zealand, producing around 2,000 cubic metres of sawn product per day, supported by approximately 250 logging truck movements daily to both manufacturing plants in the Hawke's Bay. A smaller sawmill is located in Millburn in the South Island of New Zealand. After a recent upgrade to the pulp mill, PanPac recognised that they could improve efficiency by investing in an integrated energy management system, which would allow for continuous monitoring of energy consumption across 3 sites and 2 locations. The objective was to provide management and operators with the necessary information to identify consumption trends in order to become more energy and cost efficient. The energy management system utilized many of the components we have discussed today already, including air circuit breakers with integral energy metering, web server master energy gateway modules, touchscreen graphic terminals to provide local visualization of all ACB operating alarms and energy parameters and other devices. The EM² server software solution was provided as a virtual machine hosted in the cloud at PanPac's own facility and features built-in dashboards, cost analysis, and real-time data measurements. The non-subscription based solution compiles energy data from both the Millburn and the Hawke's Bay power distribution centres and provides visualization of energy performance over the PanPac wide area network. The IEMS provides PanPac with the ability to reduce their energy bill by negotiating network tariffs, reduce running and maintenance costs, and identify cost savings where energy consumption can be improved. Well, that concludes the presentation for today. Thank you for joining us for this webinar. I hope you found it beneficial, and if you'd like to watch it again or find more webinars in this series, please go to nhp.com.au or our dedicated NHP YouTube channel. If you have any further questions about integrated energy management, please contact your local NHP sales representative. With smarter and faster decision making and seamless connectivity spurring new collaboration, NHP is enabling the connected enterprise.